30. 360. And they want us to find first derivative at 1 for the function, let's see, for the e to the x, ln of x. So when we do the first derivative, the derivative of the first is going to be e to the x times the second, plus the derivative of the second is 1 over x e to the x. So we can actually factor e to the x out. And then we take the first derivative of 1. So this is e to the first ln of 1 plus 1 over 1. So this is e, and the ln of 1, e to what power is 1? That's 0, plus 1. So our answer is e. And the next thing is 33 through 42. It just says check your understanding. And they just say determine if the claimed derivative is correct. So you're going to have to take the derivative of that function. 34 says f of x equals e to the 3x to the 5th plus x plus 1. So the first derivative is just e to 3x to the 5th plus x plus 1. And then the derivative of the exponent is going to be 15x4 plus 1. So then we look at their answer, and all they have is just this part of it. They don't have this. So it's incorrect in terms of what they're saying their derivative is. So it's f of x equals e to the negative so if we take the first derivative, it's e to the minus 0.03x. And then the derivative of the exponent is going to be the negative 0.03. So 0.03 e to the minus 0.03x. And we check that with what they say, and we're in agreement. They've written it this way, so it's correct. That's f of x. E x squared plus 4 ln of 4x. So when we take the first derivative, it's the derivative of the first, which is e to the x squared plus 4. And then the derivative of the exponent is 2x minus ln of 4x plus the derivative of the second, which is 1 over 4x. And the derivative of the argument is 4. E times e to the x squared plus 4. And this will cancel, let's see. There's an e to the x squared plus 4 that factors out of both. And it's 2x ln of 4x plus 1. And that's the first derivative. And they're saying 638. And what they say it is, it's not correct. That equals ln of e to the 6x. So the first derivative, it's 1 over e to the 6x times the derivative of the argument, which is e to the 6x, and then the derivative of the exponent is 6. So this goes out with that. We have 6. And they say 6. So it's correct. Q is f of x equals ln of x plus e to the x. So the derivative 1 over x, and then the derivative of the argument, which is 1. So then this is e to the x, and the derivative of the exponent is 1. So that's, and they have that, so it's correct.
They have minus 1 over
Oh, that's incorrect. Thank you, Joel. $44. Any questions on any of those? So the producer of tetrahydrofolate, or whatever that is coating of silicon computer wafers believes from an extensive study that the national consumption exceeds an appropriate units of PEOS over the next few years is approximated by that consumption function for 1 through 8. The study was prepared when T is 0, find the rate at which the national consumption of PEOS is changing with respect to time, 2 years after the preparation of the study. So what we have to do is take the first derivative of that. 25 T 1.2 2t plus 4t squared. Okay. The derivative of that is 14.5 e to the negative 1.2 t times the derivative of the exponent, which is a negative 1.2 plus, and the derivative of that is 0.28 t. Okay, so I suppose we should take this 14.5 times the negative 1.2. $17.4 and make it e to the negative 1.2 t 1.28 t. And then they said for time, find the rate at which the national consumption is changing with respect to time 2 years after the preparation of the study. So this is A. So negative 17.4 e to the negative 1.2 times 2 rate times 2. And I don't know if they put a number to that. So if we wanted to, we could. Three times. So, what the number is? 17 point, what is it? 4 e to the negative 2.5. That's a negative. And then it's plus 0.56. Oh, dang it. Yeah. 2.4 into that plus negative. So that's a negative 1.02. So the national consumption is decreasing by 1.02 and resisting. The national consumption in appropriate units. So it doesn't tell us what units that is in unit C prime of 5. Negative 17.4 e to the negative 1.25 plus 4.28. Six. That's 6, isn't it? Plus, no, I don't think it's a 0. 44 to carry 1.4. 1.4. Okay. Maybe. What do they do now and? Negative 1.4, negative 6. Calculator. Plus, that was 1.4, wasn't it? So it's going to positive 1.36. Okay. Psychologists believe that the formula n of t equals 85 minus 65 e to the minus 0.35t relates the number n of pages of technical textbook an average person can proofread and the number of consecutive days t that the person has been reading such books. But how many pages can the average person be expected to increase his or her proofreading ability from 4 to 5 days? So we'll take the first derivative of this. T. And this is a negative 65 e to the negative 0.35 t times the derivative of the exponent, which is a negative 4.35. So that makes the answer positive 65.32. 19. Two decimal places. 2275 e to the negative 4.35 t. So the first one, a 4 to 5 days, so we go n prime of 4. 2275 e to the negative 0.35. Okay. Negative 1.4. $22.75 e to the negative 1.4. So 5.5. When you go from the fourth to the fifth, you increase the number of pages you can read, right? Pages of technical textbook person can proofread. You increase your pages by 5.5. 4 to 5 days increases 5.5 pages. And that's A. That's it. B. So from 10 to 11. So it's n prime of 10. 2275. E to the negative 0.35. 10. To the negative 3.5. Point 68. Tenth to the 11th day increases pages 4.68. So not a very big increase. There But this is a log. It's something that is kind of like this. There's a point up here, and if you increase like this, come off like that. Kind of hit a plateau where you don't increase by much after a certain number of pages. Probably the plateau is 85, and you increase pretty fast, and then you get up there. You have a logistic function. This number right here is 85. You approach it, you never get to it. So okay, this field purification. So I look at this problem because it's kind of interesting. I have a fuel pipeline that goes through my property, and when they pump fuel through it, they pump it from Newcastle up to Rapid from the refinery in Newcastle, and they don't separate. I thought that they used to separate it with a plug of water, but they don't. They just pump one fuel, and then they just pump another fuel in right behind it. They don't mix very much, but there's some mixture. So these are multi-product pipelines, and in that particular pipeline, they pump gasoline, diesel, and jet fuel up to Rapid, and they pump oil. And the lowest grade of fuel, diesel, typically contains surfactants, chemical compounds that are attracted to surfactants surfaces and interfaces and can disrupt the coalescing process of fuel. To produce clean, dry fuel, filters contains coalescers. Clay cartridges are often used. Fuel is passed through the cartridges, and the clay triggers remove surfactants and allow the coalescers to perform their function. Normally, a string of 3 18-long cartridges is used for the receipt of the jet fuel that comes from multi-purpose pipelines. The more clay the fuel passes through, the more surfactants that get removed. A particular type of cartridge removes 15% of surfactants for each 1 foot of clay. For this type of filter, the function is given there. Calculates the percent P of surfactants that remain in fuel after the fuel passes through enough feet of clay. Just as an interesting sidebar, they were pumping jet fuel one time, and we were digging a dugout, and we hit the pipeline, and it squirted jet fuel. And there was another kind of sidebar on that. There was a motor grader that hit that pipeline. They must have been pumping gasoline through it, and it caught on fire, and it killed the guy and burnt the motor grader up. So those pipelines, we've never had a leak on our property in 50 or 60 years, except for the leaks that are man-caused. So it says, what percent of surfactants remain in the quantity of fuel after it was passed through 2 feet of clay? Round to 1 decimal. Okay. So, calculate percent P of surfactants that remain in the fuel after fuel passes through a. So that function calculates the percent P of surfactants that remain. We're saying what percent of the surfactants remain in the quantity of fuel after it passes through 2 feet. So that's just a straight 2 into that function. So 51 A is P of F equals 100 e to the negative. So we don't take a derivative of that or anything. So the percent 2 feet is 100 e to the negative 0.16 times 2. So 100 e to the negative 0.32. To the negative. That's 72.6%. So percentage of surfactants that remain in the fuel. So 72% of 0.6% of the surfactants remain in the fuel. Write the expression that models the rate at which the percent of surfactants that remain in the fuel changes as the number of feet of clay increases. Now that's a first derivative problem. So it's 100 e to the negative 0.163 t, and then the derivative of the exponent, which is negative 0.163. So that just 2 decimal places over, so it's a negative 16.3 e to the negative 0.163 t. So this is what B is asking for. At what rate is the percentage of surfactants that remain in a quantity of coal changing when 2 feet of clay are present? So C P prime of 2 e to the negative 0.163 negative 0.326. 13.3 second T negative. .7. Okay, then it says interpret the result. So when clay filter increases 2 to 3 feet, the percentage of surfactant moved increases by 11.7%. That's what that's saying. I guess that's all the columns I'm going to do. And I'm just the test, which is going to be Tuesday, 3 o'clock, right? It's going to be in this room. And what I did was, we've got 2-hour exams, right? And I've taken problems off the first 2-hour exams, changed the numbers so the answers are the same. So that you look at those 2-hour exams and know how to process those types of problems. And then I think that covered chapters 1, 2, and 3. And then on 4, I've taken out of each section. I tried to take 2, but I think some of them had a lot of word problems in them. So some of the sections I took a few more, and what I did was I'd look at each group of problems, type of problems, and I'd take 1 or 2 problems out of those types. Didn't take the hard ones, I didn't take the easiest ones. That's what I did.
How many questions are there?
I think there's 30, kind of in that neighborhood. I think I took around 10 off the first hard exam, 10 from the second, and I think I took 10 from chapter 4. I think that's it. Then the first 2 hard exams covered through chapter 3. I think that's what I did. That's it. See you on Tuesday, 8 o'clock here.